Hello dear students, good afternoon. I am Dr. Ram in front of you with the concepts of NEET JEE foundation. So today we are discussing previous year JEE problems. The problem which has been asked in JEE 2019, the problem is that a group of resistances are connected in the series, and so a current is drawn from the battery, or the current is drawn from the battery, while the battery potential is equal to 15 volts. Okay, 15 volts. So what I have to do, so the question is asking what is the current drawn from the 15 volt battery. What is the current drawn from the 15 volt battery? So current drawn from the 15 volt, what is the current drawn from the battery? What is the current? That is the question. Okay, what is the current drawn from the battery? What is the current drawn from the battery of 15 volt? What is the current drawn from battery? What is the current drawn from battery of 15 volt? What is the current drawn from battery of 15 volt? So it means E is equal to 15 volt. So after that, so the first thing, there are a series of resistances are connected. So some of the resistances are connected in series, some of the resistances are connected in parallel. If we will see the right hand side, the resistance R3, resistance R4, and resistance R5. The third resistance, fourth resistance, and fifth resistance that are connected in series. How? Because if we will see same current can flow through all the three resistances, right? Then when I will, so first I will try to find the equivalent resistances of these third resistance, fourth resistance, fifth resistance, and the equivalent resistance is given by 50 ohms. Okay, then this resistance, then that equivalent resistance is in parallel combination with this one. Okay, dear, then that resistance is in parallel combination with this one. So it means this resistance is parallel with R2, that the equivalent resistance 50 by 6. Then that resistance is in series with first resistance and sixth resistance, so that the equivalent resistance is equal to 50 by 6 plus R1 plus R6, that is 130 by 160 by 30 omega. Now what we have to calculate in this question, we have to calculate the current that is drawn from the battery of 15 volts. We know that from the Kirchhoff's law, we know that V minus IR is equal to 0. From Kirchhoff's law, that is equal to V is equal to 15. V is equal to 15 is equal to IR is equal to IR. It means I is equal to 15 upon resistance. Okay, dear, 15 upon R. What is 15 upon R? 15 upon R is means it means I is equal to 15 upon the total resistance is equal to, it has been calculated, is 160 upon 3. 160 upon 3, that is equal to 15 into 3 upon 160. Okay, so which is equal to current I drawn from the battery of potential 15 volt is equal to 9 upon 32 ampere. Okay, 9 upon 32 ampere. 9 upon 30. If we will do 3 ones are, if we will do 3 ones are 3, 5 threes are 15, 5 threes are 15, 5 threes. Okay, dear. So it will be 15 into 3 upon 160 upon 160. It will be 5 threes are 15, 5 threes are 15, and 1, so 5 twos are, okay, 3. So that is equal to 3 into 3 upon 32, which is equal to 9 upon 32 ampere. Okay, dear, 9 upon 32 ampere. So 9 upon 32 ampere. So this is the question. So this is the answer for that. 9 upon 32 ampere. So this is the answer of that. So again, I will ask you this problem. So the question is that this question has been asked in JEE 2019. A group of resistances are connected in a box, and a 15 volt battery is connected in this circuit. We have to find what is the current drawn from the 15 volt battery. So this question, so what we have done here, first this resistance, this and this, they are connected in series. I have calculated the equivalent resistance of these three resistances, and that resistance is in parallel with this one. Then after there I have found the parallel resistance of those resistances with this one, which is equal to 50 upon 6 plus 10 omega plus 50 upon, so that resistance is in parallel with this one, from which I got 50 by 6. Then that resistance is in series with first resistance and sixth resistance, and from which I got the equivalent resistance this. So now a potential of 15 volt battery is also connected there. So that means because of this, then the current derived from the current drawn by this 15 volt battery is equal to, by applying a simply Ohm's law, V minus IR is equal to 0. V is 15 is equal to IR, I is equal to 15 by R, I is equal to 15 by R, 15 by I, and total resistance in this circuit is 160 by 3. So this is how we have calculated the current drawn by the potential of this circuit. Similarly, if we will go forwards, we have another question here. So this is another problem. This is another problem which has been asked in 2020. So the question is, a group of resistances are connected in a circuit, and what we have to do, but we have to find the current in the 10 volt battery. Resistance R1, resistance R3, resistance R2, and resistance R4 is given here. And what we have to do here, we have to find the current in the battery, 10 volt battery. We have to find what's the current, what's the amount of current that's flowing through 10 volt battery. Okay, dear, through 10 volt battery. So it is 10 volt, 4 omega, 2 omega. This is 4 omega, this is 2 omega. That is 4 omega, 10 omega, 4 omega, 10 omega. This is 5 omega, 5 omega, 2 omega, and this is 20 volt battery. This is 20 volt battery. So this, so let us do, see there are, if so, in order to calculate the current in this circuit, the only thing I will use here is Kirchhoff's loop rule. Okay, the Kirchhoff's loop rule is that first I will apply the loop in this direction. Okay, when applying the loop in this direction, so let the current flows over here. So it will be the current flows in this direction. So it will be I1 applying the loop. Okay, here applying the loop, applying Kirchhoff's loop rule, applying Kirchhoff's loop rule, applying Kirchhoff's loop rule, applying Kirchhoff's loop rule, applying Kirchhoff's loop rule. So when we will apply Kirchhoff's loop rule, so it means when we apply Kirchhoff's loop rule in that direction, so IR1, I into 5 omega, I into 5 omega plus I into 5 omega plus 10 into I1 plus I2 plus, since one current goes here in that direction, another current will come through I1. So if it is I1, so if that is I1, after that let the current I1 flows here. Okay, let in this loop current I1 is there, and let in this loop current I2 flows. Okay, dear. So it means, so current I1 into 5 omega plus I1 plus I2, I1 plus I2 plus I1 plus I2, because applying the current, applying Kirchhoff's junction rule, I1 goes from here, comes from left hand side, and I2 goes from left hand side, it goes through resistance, this one. So it means I1 plus I2 into 10 omega, okay, into 10 omega plus this current will come and it will go like so, plus 2 I1 minus 20 volt is equal to 0. Okay, minus 20 volt is equal to 0. What I have done, I have taken this loop, applying the Kirchhoff's loop on, applying the Kirchhoff's loop rule on A, B, C, D. A, B, C, D, A. I have applied the Kirchhoff on A, B, C, D, A. So the current through this one is I1, and another current I2 comes from here. They go through resistance. That means over here the current is 2. The two currents will add. So it means I into 5 I1. Current I into this resistance plus this resistance into the current I1 plus I2 plus the current through 2 omega resistance is I into 2 omega minus 20 volt is equal to 0. Okay, so after that I will simplify it. So it will be 5 times I1 plus 10 times I1 plus 10 times I2 plus 10 times I2 plus 2 I1 is equal to 20 volt. Okay, 20 volt. So it means 5I1 plus 2I1 is equal to 7I1, 7I1, 5I1 plus 2I1, 5I1 plus 2I1 is equal to 7I1 plus 7I1, 5I1 is equal to 17I1 because 5I1 plus 10I1, 15I1 plus 2I1, 17I1 plus 10 times I2 plus 10 times I2 is equal to 20 volt, is equal to 20 volts. So this is after applying the loop rule on the junction on the this is after applying the Kirchhoff's loop rule in the loop A B C D A. Now this is first equation. Now applying Kirchhoff's, now after that applying Kirchhoff's loop rule, after that applying Kirchhoff's loop rule, after that applying Kirchhoff's loop rule in BEFC in BEFC, okay, BEFC, we will apply the loop rule in BEFC, so it means BEFC, so it BEFC, so we'll go like that, okay, BEFC, that means the current comes from here, so it means 10 into I1 plus I2, so it means that is 10 into I1 plus I2, 10 into I1 plus I2, 10 into I1 plus I2, 10 into I1 plus I2 plus 10 into this resistance into I1 plus I2 plus 4 into I2 plus 4I2 plus 4I2 minus 10 volt is equal to 0, that is 10I1 plus 10I2 plus 4 is equal to 14I2 is equal to 10 volt. So that is another equation. So from this circuit, after applying the Kirchhoff's loop rule, from that circuit, after applying the Kirchhoff's loop rule, I have got two equations. From this loop, I have got this equation. From this loop, I have got this loop. So from the circuit, from the two loops, I got two equations. We have two equations. From the two loops, we have two equations. From the two loops, we have two equations. One is from the two loops, we have two equations. One is 17I1 plus 10I2 is equal to 20 volt, and another equation is 10I1 plus 14I2 which is equal to 10 volt. So these are the two equations. After solving these two equations, we can calculate the current in the figure. What is the current in the 10 volt battery? After solving these two equations, we can find the current that's going through 10 volt battery. Okay, so after solving this, we got here. After solving this equations, after solving these two equations, we got I2 is equal to 0.217 ampere. Okay, so dear, what we have again, I will repeat the whole question. This question has been answered in JEE 2020. So the resistances are connected in circuit, and we have to find the current that is going through 10 volt. What we have done, there are two loops. One loop is A, B, C, D. I have applied the Kirchhoff's loop rule in this one. So it means what I have applied, that is going through clockwise like that. So that is I1 into R plus I1 plus I2 into R plus I1 into 2 omega minus 20 volt, because we are applying the Kirchhoff's voltage law, which is the sum of algebraic sum of potential differences is equal to 0. And after that, when applying the Kirchhoff's voltage law in this circuit, I have got the equation this. Then after that I am applying the Kirchhoff's voltage law in this circuit, so which is I2 into 10 omega plus times I2 into I2, since through this resistance two currents are going, one is I1, another is I2, so it means the potential across this resistance is I2 plus I1 into I2 plus I1 into R2, that's 10 omega, that is 10 into I1 plus I2 plus times 4 into I, the potential across this resistance is 4 into I2 plus times 10 volt, that's minus times 10 volt, because we are applying the Kirchhoff's voltage law. So from these two loops, after applying the voltage law, we have got two equations. One is this, another one is this. So after solving them, we have got the current, that current flowing through 10 volt battery is 0.21 ampere. After that, we have another question, and let's do that one. Okay dear, so this is another question. Okay dear, so this is another question. The question is, in the circuit shown, the current in the 1 omega resistor is, I have to find the current through this 1 omega resistor. Okay dear, so the same apply again, the same Kirchhoff's loop law I will apply on the two loops. So we have two loops here. This is 6 volt battery, this is 2 omega resistance, this is 1 omega resistance, this is 3 omega resistance, and this is 3 omega resistance, and this is the battery. The battery is 9 volt. Okay beta, okay dear, so 9, so okay, the battery is 9 volt. So what I have to find, we have to find the amount of current that flows through 1 omega resistor. So in this circuit we have two loops. One loop is APCB, another loop is PQRC. So in both the loops I will apply, this one and leave this one, I will apply the Kirchhoff's loop law. Okay, I will apply the Kirchhoff's loop rule. So when I will apply the Kirchhoff's law, so it means in loop, apply Kirchhoff's law in loop APCB. So I will apply the Kirchhoff's loop law in ABCB. So it means I will go like that. So 3I1 plus times 3I1 plus, so 3I1, so it is like that. So if that current goes like that, current goes like here, so this, the direction of current over here is there, so it means 3I1 plus times plus I1 minus I2 into 1 plus I1 minus I2, because if this is I1, if this is I2, so it means this I2, the current of the direction of the second current is like that, but if this is the direction of current, so it will go like that, so it means this current along this current through that resistance, the current of this current has a direction this, but the I2 current has a direction this. So it means the potential across the 1 omega resistance is, while applying the loop law in junction in first loop, so it means I1, that is I1 minus times I2 into 1 omega plus minus times 6 volt battery, that is equal to 0 when applying the Kirchhoff's law in the first loop. After that, so it will be 3I1, that is equal to 4I1, that is equal to 4 times I1 minus times I2, it is equal to 6 volt, which is equal to 6 volt. That is the first equation. The first equation corresponds the first loop after applying Kirchhoff's laws gives this equation. After that, I will apply the loop in loop. After that, I will apply in loop PQRC in the loop PQRC. The direction of the current is this. Okay, this is the direction of the current. So it means the direction of the current is this. Okay, so if I will take this direction, so it means this is I2 into 3. So it means 3I2 minus times 9 volt plus 2I2 plus times I2 minus I1 into 1. So it's equal to 0. So this is another loop equation. So it means that is 2I2 plus 3I2 plus I2 is 6I2, that is 6I2 6i2 2i2 plus i2 plus 3i2 6i2 minus i1 minus times i1 is equal to 9 volt. So that is second equation, which is the second equation resulting out of the second loop is this 6i2 minus i1 is equal to 9 volt. So again I am telling you the whole of the problem. The question is saying that in the circuit, we have to find the current across this resistor. 6 volt battery is connected here, this 3 omega resistance is connected here, 1 omega resistance is connected here, 2 omega resistance is connected here, and 9 volt battery is connected here, and 3 volt resistance is connected here. So we have two loops here, one loop and second loop, and we know that from the Kirchhoff's law that the algebraic sum of potential differences in a circuit, in a closed circuit, is equal to 0. The first we will apply the Kirchhoff's law in first loop. It means while going along this loop, so it means I1, this is 3 times I1, the potential difference across this resistance is equal to V is equal to IR, that is resistance is 3, that is 3 into I1 is equal to 3 I1 plus times the resistance across 1 omega. Since this through that, while considering this loop, there are two resistors, while considering this loop, the potential difference across this resistance is equal to 1 omega into the current, but the current through this resistance is 1 is this current I1 which goes like that, or another current comes from here I2. So the direction of two current is opposite, so it means I1 minus I2 into I minus times 6 volt is equal to 0. So that is the first equation resulting from the Kirchhoff's law in the first loop. Then second we are considering the loop PQRS. After applying the Kirchhoff's law in this equation, we got the I2 is that direction, so that it means 3 times I2 minus 9 volt plus times 2i2 plus times I2 minus I1, because here it is